wait till we have confirmation of the audio, and then we can start. Welcome. Shit.
You were so close to stuff.
Right, is the audio working?
Geen bericht gekregen dat hij niet werkt, maar ik plug wat mijn headset in.
Okay, then I think we should start. Welcome to the crash course for Programming 1. Yeah, let's start, I guess. So, if you want to follow along, you can download the slides. This is the URL for those inside the classroom. It's also there on the whiteboard. Thank you. And yeah, so you can download them there. It will be available for only now. And after that, it will go down.
But the slides will be uploaded to the cloud eventually, so you can still access them later.
Exactly.
Okay. And you can still access this crash course later as well, so you should be good.
Yeah. So, what are we going to do? First of all, we'll discuss all the topics that you've had for this course in the past 7 weeks. And we will discuss the bottlenecks for all the parts. And then for the second part, we'll do an exercise and Q&A.
So basically we have plenty of topics to discuss. First we'll start off with the types, the different kind of types of variables that you can have. Then we'll continue with functions and also specifically the parameters that you can pass in functions. And then we'll move on to conditionals such as if-else clauses, the switch and more. Afterwards we'll continue to loops and repetition, so we'll discuss while loops, how to increment, for loops and also the do while loop. And then we'll move on to variables, which basically includes variable declaration, constant declaration, how return works, enums, and how the scope of variables works and is indicated.
Alright, then we will continue with how input works, so the scanner and pre and post conditions, how you can work with file system, casting, exceptions, and try and catch, and the arrays will also be covered. Where we'll also shortly talk about string size and array size, the difference between them, and indexing on a string. And we'll also view how you can turn an enum into an array and work with them as if it were an array. And then we have multidimensional arrays, arrays inside arrays, so you can get matrices or three-dimensional matrices. And finally, we'll discuss the difference between call by value and call by reference, which is very important for the test and also just for knowing how your variables get changed over time. So first of all, we'll talk about the types. This is the absolute basics. You have the integers, the whole numbers, decimals, that's the double, a boolean, which is a true-false value, a char, which is a single character, and important is to know the single quotation marks. If you use double quotation marks, it will give you an error. It will give an error. A regular text, which is a string with double quotation marks. And we have enum types and arrays, but we will cover those later as they are more complex. Every bit of your code is wrapped inside a function, and your main function is the function that is called by default. It's this one. The most default type of a function is a void function. It returns nothing. It just executes your code, and you can.
Yeah, the problem is using wrong power point.
It's using wrong power point.
Yeah, the string is not changing.
Okay. Let's see what we can do about that.
Is the volume okay for you guys, by the way?
If they use this one, so instead of this one.
Okay. Yeah. Of what?
We're too far now.
Ja, nee, het is ook niet.
Kan je even met dat ding stoppen wat ik heb?
Ja, dat doet je dus niet.
Ja.
Zie je de volume?
Dat is het nu wel?
Ik kan stoppen met het ding gelijk alvast te maken.
Dat is ook een Goed zien. We can try the PDF.
What's the problem?
Yeah.
It's not updating the slides on stream.
It's not streaming the.
It's not streaming the right thing.
Oh,
Like it's not streaming this.
Yeah. Okay. Then.
Where's Thomas?
We will be right back. I think we'll try and fix this.
Short technical delay.
Oopsie. Let's see if we can fix this. Zo kan ik niet.
Ja,
Spence.
het werkt.
The other people were kind of relieved it was cancelled.
Does it work?
Yes, it works.
What day?
All right.
We are live.
We're back. We hope.
Hope you're ready.
Okay. Sorry for the inconvenience. The PowerPoint window was not able to be streamed, so.
Oh, that's not stream my WhatsApp
Yeah.
conversation.
It's on the diff. No, we can leave from here. Sorry. Yeah.
I was like, hold up.
I wanted to switch to Windows.
Okay, cool.
Okay.
Anyway.
So, the main function will be run on startup, and it will basically just execute all the code which is inside this function. It's also a void function, so it doesn't return any information. Alright, then we have every bit of code that's being executed by your functions should be ended with a semicolon, otherwise your program fails. However, if you have curly braces somewhere, you don't have to close the curly braces with a semicolon. So everything inside the curly braces should be ended with a semicolon, but the curly braces should not. So that's that. Then when you have the main function, this part should always be in there. Why this doesn't matter for this course, but it should be there. So if you make one, make sure it is there, otherwise your program will not run. And when you call a different function, you should add the parentheses behind it. Otherwise it will not execute the function. So when you have a function called do something, you have to, if you want to call it, you have to add the parentheses. And when you define it, you also have to add the parentheses. Alright, so your functions can also have parameters. So when you have your function, you can pass values onto the function, and you can, for instance, add it like this, and then this part over here is where you define it. And when you call it, you have to give the values in the same order. So, for instance, if you have to do something, in this case with an amount and a product, this 2 over here will correspond to this one over here, as that one is the first parameter here, and this one's the first parameter here. And the apples will correspond to this one, the product, as this one is the second one, and this one's also the second one. Now, once you define your parameters, you should add the type. So the types we discussed at the beginning of this crash course. So you should add them right here. But when you call them, you don't necessarily have to add these values again, because it already knows this, because you either give a single value, like we do right here. So this is just a number. So it already knows, okay, it's an int. Or you give it double brackets, or what do you call it?
Print. No.
No, quotation marks.
Quotation marks.
And then it knows it's a string. So it already knows that, and then it will automatically fill it in over there.
Also because of the order.
Yes,
So
the
that's
order
like that.
is really important here. Okay, then you have comments. Everything behind 2 slashes is not going to be executed. So when you have 2 slashes with a piece of text, it will just be there so that you know what this function does, or you can just explain something inside the code, but it will not influence how your program is going to run. Also, you can do it like this, so then you don't need 2 slashes, but if you do the second approach, you can do it on multiple lines. So you can just open them once with this part, and then you can close it with this part. So you can just have comments on multiple lines.
It's very important to add this last bit, because if you get it, then all the code behind it gets commented as well,
So
and
then
you'll likely have many errors.
Exactly. So then your program breaks. Alright. Then, now that we have talked about the basic functions, we also have conditionals. And conditionals are, okay, if something is true, then we execute this piece of code. If it's not true, then we execute a different part of code. So it will do this based on the condition over here, and when that one is true, it will do the part inside the if statement, and if it's false, it will do the part inside the else.
Yeah, so basically you add a boolean as an if condition. A boolean is something that is either true or false, as we discussed earlier. So for example, if you want to write a function that checks whether a certain integer, a certain value is bigger than 10, then you get the value as a parameter, and you pass it on to an if clause, and then the if checks, hey, is this value actually bigger than 10? If so, then this will be executed because the if boolean was true. If not, then the else gets executed, namely the number is not greater than 10. You can do the same for another boolean. For example, is your number, your value, equal to 10? In this case, number is equal to 10. In the other case, number is not equal to 10. And we have many different comparison operators that we can use. We have the two equal signs, namely equal to. We have the bigger than, greater than, larger than sign. We have the smaller than sign. Bigger than or equal, and definitely make sure that you write it in this order, because the other order will give an error and is wrong. And then you finally have the not equal to sign, which is basically just an inequality. And you've seen some of these before in our previous examples. For example, the larger than, greater than sign and the equals sign. So when you use a boolean, when you get a boolean as a parameter, it is very important, and I repeat, very important, to trust booleans. Booleans are true or false values themselves, actually. So if you write show answer equals equals true, you'll actually be writing true equals equals true, or false equals equals true, and that is wrong. You can just immediately pass it as it is a true or false value itself.
Yeah, your program won't crash, but it's just better if you do it like this.
It looks really ugly, as Sparky would say. Furthermore, if you want to compare two strings, you cannot use the equals equals operator. Why this is beyond the scope of this course, and you will learn it in object-oriented programming. But if you do want to compare two strings, such as string 1 and string 2, hello, you can use the function equals. This is also very important.
If you do this on the test, then your program will crash. So this one is really important.
Yeah. So basically, if you have a nested if-else clause, basically what that means is you have an if and an else clause, and inside the else clause you have another if and else. If you want to add that, then you don't have to write the else brackets anymore. Basically, it just means that you can immediately write it like this, and your programmer, your compiler, will know, all right, this is a nested if-else clause. And sometimes a value can take on many different values, and you want to condition on several different possible values of that variable. So instead of writing a large cascade of possible ifs, like for example the variable a can take this value, or else a takes this value, or else if a takes this value, it's much easier to use something called a switch, which takes a variable and lists all the possible values it can take in different cases. And if it takes one of the values, then that specific code will be executed. So for example, if variable takes value 1, then this bit of code will be executed. And if it takes value 2, then this bit of code will be executed. A very important bit to add is that you must use break here, because if you don't use break, then it will still go through all of the other cases below it. And if it matches with multiple of them, then you will have multiple lines of code ran. Well, that's not what you want that to happen. And finally, you can add a default case. In case your variable doesn't match any of the previous values mentioned in the previous cases, then you can then the default code will be run, and that's this bit here. So if you want something to always happen, even if if you want something to happen in the case of there's no other case that matches your variable, then you can add a default case. So this is an example of a switch. So for example, if you have the command square and you have the integer 4, you can add the you can add the command to your switch, and it will check, okay, which command was issued. Was it a double? Was it increase? Was it square? It matches with square, so what it will give a new value for x, namely the square of x. The other values will not happen because the command didn't match with any of them. Furthermore, you have numerical operations, which you can apply to integers and doubles. You basically already know them from maths. Maybe not this one, but the other ones are very simple mathematical operations, such as addition, subtraction, multiplication, and division.
And the modulo,
And the modulo, of course.
which gives you the number. If you divide, it gives you how much is left after I did the division. So if you divide 13 by 4, then you have 1 left. So 13 modulo 4 will be 1.
Yeah. So you can use those in your if statements as well. If you have two variables and you want to check whether they're a certain amount, if they're equal to a certain amount, or if they're larger than a certain amount, or whatever, you can add them and you can use those operators to check that. So for example, A and B are both 2. 2 plus 2 is 4. So if that's the case, then this statement will be printed. If that is not the case, then nothing will happen. It is very important to know the difference between int and double. So basically, if you divide I by j, which are both integers, then the output will be 1. This is because both of them are integers, and integers cannot handle decimal numbers. Basically, what it means is if you divide 2 by 3, I think I wrote that down wrong, but if you divide them by each other, then the decimals will just be cut off. It will not be rounded, the decimal will just be cut off, and it will just give a 1, which is not the correct answer here. If you divide by a double, then it will give the correct answer, because, can you go to the next slide?
Mm-hmm.
A mathematical operation between two integers always yields another integer, and the decimals will be cut off. And a mathematical operation between an integer and a double will always yield a double, which will indeed give the correct answer here.
Yeah. So
Also be careful to never divide by 0, as this is mathematically impossible and you will get an error as well.
yeah, and it will definitely not round off. Keep that in mind. If it's normally would have been 1.8, and it will now be an integer, it will just be 1. It won't be 2. It will just be 1. It will
Yeah.
just remove the decimals.
Yeah?
So a double does not cut off the decimal?
No, a double is basically just a decimal number, and the integer is just a whole number. So integer is 1, 2, 3, 4, and a double can be anything with any amount of decimals.
I actually had a question for the switches.
Yeah.
So if we have multiple values that are true within one case, how do we write this? We say like x equals 1 comma x equals 2. Like if multiple things can be true for one thing to happen.
I don't think that's possible with a switch.
I mean, a switch just it checks the value of a single variable, and a variable will always have one value.
Yeah.
So it doesn't make much sense in a switch statement to check, okay, this variable has this value and it has this value, because it has one value.
But like we had an exercise with like the days, like the months,
Oh.
how many days they have. So to say that January,
Oh.
March, whatever, then those all have 31. How would you?
Yeah, okay, so
You might be able to use or.
no, in that
or.
case you can use the different cases underneath each other, so we don't have an example of that, but I can
Oh.
show it to you.
Yeah,
if
right,
you
I
want to.
remember.
Yeah, so then you can just remove the code here and break, and you can remove the code here and break here. And then value 1 can be Monday, value 2 can be Tuesday, and value 3 can be Wednesday. And then if you only have one piece of code here, in all these cases, if one of these will be true, then we'll just run this.
Yeah,
So
that's the bit I mentioned, that if you take out break, it will continue going through cases. So if you want multiple cases to possibly match, then you can just leave out break, and then it will still go through the next
Yeah.
case. The moment you put a break, it stops.
Yeah. So also then if you do use Monday, Tuesday, and Wednesday, then also take out the code here, because otherwise you run some code for Monday and then something for Tuesday, and then that will not make sense. So then you can just remove that part altogether.
Yeah. Was there a question in the back still? No.
Just the answer.
Which one, right?
We were next
Yeah.
one.
Next one.
Alright, and as you may have seen in the exercises before, you can also use modulo to check whether a number is even or uneven, as uneven numbers get a remainder of 1 when you divide it by 2. So for example, if you have the number 4, 4 modulo 2 is 0, as 4 is divisible by 2, which means 0 remains. If this is the case, then you know that your number, your variable a, is indeed an even number. And the same holds for b. b is 3. If you divide 3 by 2, then you have a remainder of 1 if you use modulo. So that means this number is uneven.
Okay.
And if you were to like to show the numbers a and b that we just kept using, then you can use string concatenation by using the operator plus. So basically, you add an integer inside of your print statement, and using when you use the plus and add a string after it, the compiler will see that this is supposed to be a string that needs to be printed. So it will insert the 4, the integer, it will turn it into a string, and it will add it to is even. So if you do this, then you get 4 is even. And the same holds for the number b is uneven, and a is larger than b. It's basically just a way of taking multiple strings and then combining them together to form one big string. And you can do that with the operator plus. Do pay attention to the fact that
I have a question about the previous slide. Are the spaces important for you? Do you forget to add spaces?
yeah, I added it because if you don't add the space here and don't add the space
Add the
here,
space.
then the number will basically be in between text. If you
Yes.
want it to look nice, you add the spaces.
Yes, with the space over here, this one is not important.
No, exactly. And you can also leave it out here, it'll just look ugly. So that's why I added it.
Thank you.
Do note that the order is important and that there's a difference between the mathematical operator plus and the string concatenator. Because if you were to use it like this, and if you were to print this, it will first look at this and it will see, oh, 2 integers, we can add those. That's 6. And afterwards, it will concatenate it with a string. But if you do it like this, for example, then it will first take the string, and then it will concatenate the 4, and then it will concatenate the 2, which will give you 42. So it is very important to look at the order. This will give you 6, this will give you 42, and this will give you 24, because there's a string in the middle. So it will go from left to right. So definitely pay attention to the order in which you concatenate.
Yes. All right, loops. So a loop can be used to execute a single piece of code multiple times without having to duplicate your code in any way. This is extremely useful because if you write your code every time again, then you get your code prone to errors and you have to do much more work than if you just have it at one place. But one very important thing to know about the loop is it will only check the condition once at the start of the loop. Then it will execute all of its code, and only then it will check the condition again. Let me give you an example. If you have a while loop with a condition, it will check at the start if the condition is true. So let's say you check for x equals 4 or something. If x is 4 at that time, then it will run. It will run all the code here. And if you, for instance, change the variable that determines the condition, so maybe you change x to 5, this is not true anymore, but it will still just run all of this code. It will just finish what it has started. It won't be interrupted. So that's very important to know. It will only check the condition at the end again. Yeah, so as an example, this is how a default while loop looks. So you can just have like an integer example, that's your counter in this case. Then you'll check, okay, as long as my example is lower than 5, then I'll run this code. And at the end of my while loop, I'll increase my example by 1, and this will print hello world 5 times. So there are different ways to increment, like how you saw in the last slide. I used example equals example plus 1. You can shorten this by saying example plus equals 1. This also works. It's shorter and it's more useful. And you can also use example plus plus. This increments by 1. So you can only use this if you want to increment by 1. And you normally do want to increment by 1, so this one is very useful. If you want to increment by 2, you can still use this one or this one. But I would always say like use this one or this one, but never use this one because it makes no sense to use. This is just extra code. And if you have a while loop, most of the times you can change it to a for loop. Like for example, how I used the while loop previously. I had an integer example, and it will just check if the example is smaller than a certain number, and then at the end it will increase. Well, that's a very common way of writing loops. So in Java created a new way of doing that, and it's called a for loop. So the code that I wrote here, I can add here. So that's the initializer. I will show that in the next slide as well. I can show it right now actually. So you have an initialization, a condition, and an incrementer. So basically this part is run at startup. So at time when your for loop starts for the first time, it will run this piece of code. Only for the first time. So when your loop runs again, it will not run this again. This is the condition. As long as that one is true, it will repeat the loop. And then at the end of your loop, it will run this piece of code, and it will just run that every time your loop ends and ends and ends, it will run that again. So this one only called at startup. How can we do this in practice? Well, just like I showed, this piece over here, so you still need the int in front of this, just like you did here. The condition in the while loop, you can just copy it to here, as that is the condition for the for loop, and where I incremented at the end for the while loop, I can just add it here. It will do exactly the same thing, but it just looks way better and it's less prone to errors, because if something doesn't work about your loop, you only have to look over here, while in the while loop you could have done your counter over here and it would just be messy and it could just give you errors like you didn't even know that where the errors could come from.
Question in the back.
Yes?
So the for loop runs until the end of the incrementing or until the condition is met, or both?
The for loop does exactly the same thing as the while loop, it's just a different way of writing. So it will just continue to run and run until the condition doesn't match. However, where I, in the while loop, have all these pieces of code that are important to the loop at different places, for the for loop, it's just in one single line.
Yeah.
Which makes it much easier for you to understand and also less prone to errors.
So yeah, example 2 will just keep increasing until it is larger than 5, and then the for loop will stop as well.
Exactly. Does that make sense?
Larger than or equal to 5, as this is smaller than 5.
Yes. Yeah? Okay. So I talked about this one. Yeah, so when you can use a for loop, it's very much advised to use a for loop. So when I just show you with my while loop, it was ugly, it was terrible. So this while loop you almost never want to do. So I can write this while loop as a for loop by just doing it like this. So I should do it like this, because this is ugly and bad. Some while loops you cannot turn into for loops, and then it's fine to have a while loop. They also have a function, it's not that they're useless. But if you can write your while loop as a for loop, you should do that.
Basically, if you're increasing or decreasing a value every iteration of your while loop, then you can turn it into a for loop. If it does something else, then it might not be possible.
Exactly. Yeah, so you don't necessarily have to increment by one. That's also an important thing to know. It's common practice to increment by one, but you can also decrement by using the minus equals instead of plus equals, for instance. You can decrement by 2 if you want to. It will make your code very messy and it's not advised, but in some cases it is better to decrement. And the test will also decrement to get you confused, so it's important to know that you can do it. So if you decrement, it looks like this, or minus minus if you decrement by 1. And then it just goes from 10 until it's no longer bigger than 0. It just works in the same way, but just the other way around. With for loops, or loops in particular, it's very important to check how many times does my loop actually run, because a little change in your code can make your loop run a different amount of times. This one loops 5 times, and this one loops 6 times. And if I didn't highlight this, you probably didn't notice. Things like this you can expect on the test, because these are very subtle changes, and it can really make your life difficult. So what's the difference? Here it will loop until it's no longer smaller than 5, and here it will stop looping when it's smaller than, or when it's no longer smaller than or equal to 5. So this one will stop when example is 6, and this one will stop when example is 5. It can be a very small thing to notice. Okay. Yeah, so if you have a for loop with only a single line, you can remove the curly brackets like I had over here. Then it will just run this single line for that amount of times. And in the test, they sometimes use this kind of format, so it's useful to know that this is allowed and you can use this. It's not wrong, it works. Same goes for if and else. So if you have a single piece of code inside your if, only one line, you can write it like this. So then it's just this if condition, and then we'll just run this line until the semicolon, and then it will stop with the if condition. So if you have multiple lines, you should use the curly brackets. If you have a single line, you can use this. It's not wrong if you don't use this. It's just good to know that you can do this and it's not wrong.
Sometimes you can have a lot of brackets, and if you want to reduce the amount, you can use stuff like this to simply make it more clear for yourself.
Yes. If it helps, it's a good practice to do so. Alright, then we have while true. It's not a different kind of loop. It's just the way while works. It's just, okay, piece of code forever. So your program cannot stop on a normal way. So this is not really a way you want to do it normally. Like, there are some minor applications that you want to use this, but don't ever use this yourself. But just know that it is possible to do it like this, and sometimes you have to do it, but then maybe explicitly mentioned.
Of course, the antagonist while false, but that's nonsense because the loop will never run.
Exactly. Alright, and then also a different piece of important information is to never ever use break inside your loops. Where we just showed that in a switch you have to use breaks, you are not allowed to use a break in a loop because we're trying to teach you that your loops only stops when the condition is false. And if you're going to use breaks inside your loop, then it will also, for instance, stop when you type break, and that's not how we want you to do this course, and it will be graded wrong. The while true can only be stopped by break, but again, don't ever use break, so don't do it.
In loops anyway.
In
switches you are supposed to use it.
Yeah, exactly. This is how break works. It's pretty neat. Alright. Then you also have the do while loop. It will execute the code first, and then it will check if it should run the code again. You'll think, okay, in what way is it different? Well, in this case, it's a little bit odd, because now I have an example that is 10, and my while checks if my example is smaller than 5. So if you had a normal while loop, it would not run. But because I have a do while loop, it will just run this code once, and it will check, okay, is my example, which will be 11 at this time, smaller than 5? It will say no, so it won't run it again, but it at least ran it once, so I still get an output. If I have example 0, it will just run this and it will see, okay, it's 1 is smaller than 5, I run it again, and it's just what you would expect from a while loop. So the do while loop is a variation to the while loop. Okay, so short overview. What loops did we have so far? We had the for loop, which is a nicer way to write your while loop if your while loop increments by 1 every time, or by 2, or decrements. But when you have a counter, you usually want to use a for loop. Then we have the while loop, which is the standard loop, and we have the do while loop, and it's a variation of the while loop, as I just explained.
Alright, does anybody have any questions whatsoever so far about the things we discussed?
When do we use do while loop?
Yeah, I have to think about a use case. Yeah, okay, so when do you use a do while loop? That's a good question. One way when you can use it, for instance, is if you want to get user input from a user, and you just want to ask, like with the example that we had with the assignment with the quadratic formula solver. You had to ask the user for a number for a, but when a was 0, it would no longer be a quadratic equation, you would just want to ask the user again. So you, per definition, you want some value for a, so you just write do and then ask the input from the user, and then you'll check, okay, is this input equal to 0? Because if so, then we just ask it again. So that would be a way or a use case for do while, where you just always want to have a value, and then you can just write that in the do, And then if it's not correct, you can just repeat with the while loop instead of having to ask and then write the while loop and then ask also inside the while loop. So it will be double code.
Repetition of code is often not a very good idea.
Yeah.
So this prevents that.
That's a good use case. You also had a question?
So the thing I asked before, is it possible to do with ORs?
Yes, so every condition, so everywhere we write conditions, so it goes for if statements, it goes for while loops, for loops, and do while loops, not for the switch statements, because they don't have conditions, but for the if, else, if, and then the loops, you can combine two statements with or with and. Did we cover that?
I don't think we included that.
Oh,
But yeah, you can use two and statements or the two vertical bars to include an or,
Yes.
to include an and then it will check. For the ands, it will check are both of them true. For the ors, it will check is either of them true.
Yeah, at least one of them should be true. If
Yeah.
they're both true, it will also
It
be.
will also
Yeah,
run,
okay,
yeah.
we should maybe, we'll do cover that maybe in the end.
If statement, would you have to write x equals that or x equals? Or
Yes,
you
yes,
have to
yes,
write
yes. Yeah. That's why when you want to check for multiple values of a variable, you often use a switch statement. This is more convenient.
And in the exam, isn't like alignment of the paragraphs really important to do the?
I don't know if they.
Didn't hear
Okay,
the
yes, it's very important. I hear from an anonymous source. It's very important to keep your alignment correctly.
Okay.
Okay.
Yeah. Otherwise, it will get very messy and unclear for both you and the corrector.
Yes.
You will frustrate whoever is grading you, which
Yeah.
will lead them to see more mistakes. I have heard.
Okay. Okay.
Alright, then we have variables. These are the types that you have seen before. So the int, the double, the boolean, the char, and the string. So basically, if you want to use or define a variable, you need a data type. So that's the things we just mentioned, the int, double, etc. You need an identifier, so that is a name that you will use to call on the variable later. And you give it a value. This is optional because you don't necessarily immediately have to give it a value. So for example, if you want to define the variable an int number, we call on the type, we call on the name, and then we add a semicolon because we don't want to give it a value yet. But the line after, we do want to give it a value, we want to make it 5, then we can say number is 5. The second time you don't have to add int, because we already defined that number is an int. You can also do this in one step by saying int number 2 is 6. So this first step is called declaration, and the second step is called initialization. And both of these can happen at the same time.
Yeah, and just I want to emphasize, if you do it like this, the next time you want to change the value, you don't need again this, it's already defined. And even though you do it here, if you want to change it to 7 or to 8, you can just write number 2 equals 7.
Yes.
Because you already defined it.
To use variables, they do need a value. Does anybody, why do you think you do need a value here? What do you think this would lead to an error?
You never define what known is.
Yeah, exactly. You cannot perform a mathematical operation of multiplication with nothing. That
Yeah,
doesn't work. So this needs to be a value. This needs to be 2, 3, minus 700, whatever, for you to use it in a multiplication. So this has not been initialized, and therefore you cannot use it.
Okay, this can, because it's 0 by default for int. So it will just be 0. The unknown value is 0 by default.
Oh, right.
Because it's an, okay.
Sorry.
Now don't worry, but if it's a type without a capital letter, it
Oh,
will
yeah,
have
I
a
will say-
default value. We'll come to that later, but it will just not be what you expect. Now it will just multiply with 0, because when an integer is not defined, it will just say, okay, it's 0
Yeah.
by default. We'll explain this in more depth later on, but you will still get a problem because it's not what you would expect as your output. So always give your things a value.
You can also define define variables as constants, which means that you want to give them one value when you initialize them, but you don't want that value to change. So basically, you just add the term final, which also makes sure that the program does not allow you to change this variable, which is now a constant. Often these are written in capital letters to emphasize the fact that they are constant. For example, the number pi, it will never change. So you can define it as a constant, so to really make sure that if you use pi, you always use the same number. So far you have only seen void functions. You can, however, also use different type of functions. For example, by adding a type to the function, and then you also have to add the line return. If a function has a return type, for example int or double, then it always has to return a variable or something of this type. So for example, here we have a function +5. We have a function +5, which is an int function. So that means it has to return something that is an int. New value here is defined as an int because you get, I think there's a mistake.
Oh, yeah, that's a mistake.
Yeah.
Ignore that.
Well, new value is an integer, so that's why you're allowed to return it here. So if you call on the function +5, it will return an integer.
Yeah, this is a mistake. It should be int new value equals value +5. So this doesn't work, but
Yeah, the idea is the same.
yeah.
You can also simplify it by, you don't have to declare a new variable. You can also immediately use this function, as this function is substituted by the value itself. So this is exactly the same as the value that you return here. So this returns an int, so you can immediately use it. You don't actually have to declare another variable in order to use it.
Yeah.
That's why this does the
So this time it is correct. So you can do this, and then it will just become value.
Yeah.
Does that make sense? Is it clear to everybody? Okay.
Yeah, this is the bit I mentioned just now as well.
Oh, yeah.
So
Skip it or
yeah, I could just use this example. So basically, if you have the function +5 and you add 5 to your value, then this is actually just the same as this. That is why you can also just add +5, 3 to your print statement, because it's literally just 8. Since you added 3 as a parameter, and this function just adds the number of 5. So what do you think goes wrong here in this bit of code? Pay close attention to the details in relation to what we just discussed. Yeah?
Possibly because the thing like the void,
the return
the
type?
value +5 is an integer and it's not void.
Exactly.
You have to
exactly.
return null.
A void function never has a return type, and that is why it's not allowed to return an integer here, so it will give a mistake here. What it actually should be is on the next slide.
Yes, I think it is.
Yes.
Yes. Oh, it explains it here, and then
Yeah,
this is the
it's,
solution. Yeah.
it should be.
Oh, no, it's not the solution.
This
it's
is the next one. This bit should be int, and then it will combine correctly.
All right.
And what goes wrong here?
The integer.
Yeah, same story. It has int as its return statement, but there is no return statement in here. It's just a print. So it will complain that nothing gets returned. It doesn't get a value, so you can't use this function. This needs to be void.
All right.
Alright, so you also have enums, and enums have methods like, wait, I think we skipped one slide.
Did we?
Did we not? No, never mind, we did not.
Oh, we
yeah,
did.
we did.
Yeah.
Okay, so basically, enums are enumerations of many constant values. You have seen this in your assignments with the days and the months of Easter, I think. So basically, if you want to define an enum, you can enumerate all of these constants. So you have all the days in the week, and you don't. It might become clearer for the user that you're actually referring to a day. It is defined as this. You can, for example, you can have a variable today, and day will become like a new type since you define an enum, and then you can say today is day.tue because that means Tuesday. But you always have to add day as it's an enum, and that's the syntax of enums. And there are many functions that you can use for enums. For example, you have ordinal. And ordinal, if you use that function on day 2, then you will get the number 1, as it is the second value in your list of constants, which is pretty useful if you want to, for example,
Start
loop
at 0.
through. Start at 0, yeah. For example, if you want to, just get the number in the list. Then you have equals, which allows you to check whether 2 days are the same. So for example, day 2, Tuesday, is not the same as day Wednesday. And then you have name, which is if you just want to get the Tuesday bit, you want to see what you want to get that as a string, then you can use day2.name, and then you will get Tuesday as a string, if you want to print it, for example.
This is very useful if you want to use it in a for loop, for instance, because then you don't have to type it all out yourself. You can just use this functions and just like this.
Alright, then you also have scope, which is actually pretty important for your test, I believe. So basically what it means is that variables defined inside curly braces are only available inside those curly braces. So for example, if you have the value here, and you pass it on, you don't pass it on to +5, you cannot use it here, as it has not been passed as a parameter. This function will not know what value is. It's only been defined inside of the main function. So if you want to use it in your +5 function, you will need to pass it on as a parameter to make sure that +5 also knows what value is. This holds for other things with curly braces as well. For example, with if statements and for loops. This text cannot be printed here, as we have defined the variable text inside of the if statement. Therefore, it is only available between this bit, and this print statement will not know what text is. If you want to use that, you will have to define it before you call on the if statement. So basically, if you define test here inside the for loop, then only this bit will be only text will only be known for this short bit. It will also not be known for the condition here. So you can also not use text in the condition, as you have defined it inside the for loop, which means you cannot use it outside of that scope.
Yeah. So here it can print because now it's in the scope.
Yeah. So what goes wrong here? Yeah.
The defined integer lies within the curly braces.
Exactly. Yeah.
Yeah.
And how would you fix it?
You would either you could put the int y outside and then define y equals y inside, or you just take it beyond.
Yeah. Okay. You cannot take the return inside the if statement, because then if this is not true, then there's no return statement anymore, and then your function will crash. So the only solution is to take it out. Yeah. Okay. Should we do a break?
We could do a little break.
Could we put the return up and then have return 0?
Yes, you could do that as well.
You can have multiple returns as well if you want to. And if you do if else and have a return in both the if and the else, then it's fine as well.
Yeah, because the else will always be triggered if there's no if. Okay, so we do a little break, then I think that will be okay.
Heftig. Nog verder dan dit zelfs.
Yes, alright, so
Zijn we live?
we're live?
Sorry.
Yes, alright.
Brace yourselves, it continues.
Yes. Now we'll get to the difficult, more difficult parts. It's still doable. Alright, so you also have a way to get input from the console. So far we've only done system.out.println to give output to the console. But sometimes you want to ask your user for input, and then you can use a scanner, for instance. The default way to make a scanner is using this. So scanner, you give it a name, so you can call it scanner again, or in this case input, to differentiate. So if scanner input equals new scanner, and then system.in over here, just remember it. And when we have that, we can call certain functions on our newly defined scanner, namely it's called input, so we can say input.nextInt. It's case sensitive, so check where the capital letters are. And if you do this, you'll get the next integer a user writes inside the console. So maybe they type 12 or 13, and then it will just catch that. If user writes a piece of text like hello world, then it will just ignore it until there's a number in the console. We also have input.nextline, and it will just return the next line a user types. So it just types a piece of text and then presses enter, and then when enter is typed, you get the entire line inside your code. We also have next. It will just take the next word. It slices on spaces. So when you have hello world and you do input.next, it will be hello. And input.hasNext will check if there is still a word left that the user typed in the console. And if that's the case, it will return true.
Yeah, that's typically what you put inside of a while loop.
Exactly.
So if you want to get if you want to get input like multiple times, then basically you add hasNext, and then you continuously repeat the function input.next to get this sentence word for word for word for word.
Yes. The reason why this is underneath each other is because we print a line. So we just print a word on a line, then we print the next word, etc. You could, for instance, say string text is equal to input.next, and then you could do something with that. So you don't necessarily have to print it immediately. You can also assign that value to a variable, so you can reuse it. Yes?
If you use print instead of print line there, will there still be spaces in between?
No, that's a good question. Okay, so the question was, if you don't do print line but do print, will there still be spaces in between? And the answer is no, there won't be spaces anymore. It will cut on the spaces, and then the spaces will be removed. So then it will just be one long string of text. But it's a good question.
What you can do, however, is use string concatenation and add plus, and then between quotation marks a space. However, then there will be a space at the end as well. So if you want to prevent that, then you have to do something else.
Yeah.
But you can add spaces manually.
Exactly, but there's always like the next line, and you get just the entire
Yeah,
line.
that
as
might
a
be
string.
better in that case.
Exactly, but it's good to know how it works. This is an example of a next line. So we take the value next line, put it into the string called response, and we can just print it later on. And say, for instance, your response was, and then something else, and then this will be the output. It will be underneath each other. Then we can also do this for integers. If I type 10, it will just do 10. But this will only work on numbers. And the funny thing is, and I probably should have made it more clear, you can, because it will return an integer, you can just add to it or subtract. You could just say, okay, 5 plus 2, or I can say like grade plus 2. So I'll just increase your grades, like we do with the Scratch course. We increase your grades, and you can do it like this as well. So because it returns a number, you can do mathematics with it. Okay, was this still part?
That's
Great. Yes. Okay, so preconditions and postconditions. This is very important for the test. You will lose so many points if you don't do this right, so please follow along. Alright, preconditions are assert statements, and they are at the top of your function, first line inside your function. and they will check if the values inside the parameters, so the parameters, if they have valid numbers or values in general. And the post conditions, I'll explain them a little bit more in depth later on, but the post conditions are to explain your function, and we use Javadoc, and we'll just explain, okay, what will be the output of my function, what does my function do, yeah.
You actually only have to give them on the exam when it explicitly says so.
That's a very good point.
Which is not on most questions, so if you're gonna write them, make sure you actually have to, because otherwise you waste half the space and you get problems.
Yeah, a good point. Okay, so when you do the exam, you don't have to do it for every question because it takes too much time. But there will be specific questions where you'll be asked to write the preconditions for that function. And if you don't know what preconditions are or postconditions, then you have a problem. So you will not have to do it unless specifically answered on the test.
Yeah, I wasted a lot of time on my exam because I was doing that the entire time. And then my exam became very ugly because I scratched everything out. So prevent yourself from doing that, and then you should be fine.
Yes, but they still cost you a lot of points if you don't do them correctly on the questions that they ask it from you. So what are preconditions? Preconditions are assert statements at the top of your function. For example, we have a square root, and because we're not here at applied mathematics, we don't have imaginary numbers, and we can only take the square root of positive numbers. In this case, you can check if your value is a positive number by doing it like this, and if it's not, then you give an assert error like this. So this will be the error message if it's not right. But one very important thing to remember is you cannot, or you can, but you're not allowed to use assert statements as if they were regular if statements. You're only allowed to use assert statements to check for mistakes by you as a programmer, but not by mistakes of a user. So you cannot check, okay, did my user type Amsterdam or Rotterdam? No, you should only check if you as a programmer made a mistake that could crash your program, but not if you just want to check for which city they want to go to or what grade they want to have, whatever. So it can only be to prevent fatal errors in your programs, and it can only be at the top of your program. Now, one very common use case for preconditions is the assert on null. Every variable that you pass as a parameter with a capital letter, so that includes strings, but also some arrays of strings. Int arrays don't, because they start with a small letter. We come to that a little bit later. But everything that starts with a capital letter, so enums as well and strings, and you'll see plenty more in object-oriented programming, they can be null. And null means nothing. I'll show that in a little bit. But every time you have a parameter with a capital letter, you have to specifically add an assert statement. If asked by the exam question, you have to add this and check if it's not null. Because if it is, and by the way, you should give it a plausible explanation what went wrong. You should say, for instance, S cannot be null, but you have to check this. Now, what is null? Null means absolutely nothing, and that was also with the question with the int unknown. Like integers, or booleans or doubles, they have all small letters when you define them, and those are the primitive types. So everything whose type does not start with a capital letter will have a default value. Did we add it here? No, we did not. Okay, we will show you the default values a little bit later. But for instance, on an int, when you create it, it will be 0 by default. But for strings, because they start with a capital letter, when you don't define a string, it will be null. And whenever you try to call a function on a string that is null, your program will crash. So whenever you have those types where they start with a capital letter, you always have to do this because your program will crash if you try to do anything with your string because it's null, it doesn't exist. That's basically the conclusion. So that's very important also for your test. Please highlight that very good. Yes?
2 pages back.
Yes.
It says assert s equals null. Is it supposed to be equals or?
Yeah, now the funny part is I forgot to add an error message, which would have made it more clear. But you always check, if it is this, then I give an error. And I forgot to add an error message. So you basically check, okay, if it is null, then I give this error message. But I did not define an error message, which is a mistake. But this is correct. So it will just now say, okay, this variable is null, we will stop with it. But that's what they want.
If you want to see if something is equal to null, then you do use the equals signs.
Oh yeah, that's also a very confusing thing. We just told you that you are not allowed to use equals on strings, and you should use dot equals, but you cannot use dot equals on a null value. That's the thing that we try to convey. If you try to call any functions on a null value, your program will crash, so that would not work. So which is why you have to use the equals here. It has a more in-depth explanation. You'll get it in object-oriented programming. But for now, you just have to assume that if you want to check for null, you do have to use the equals. If you want to check if two strings are equal in any other way, you have to use dot equals.
Yeah.
It's very confusing, but just keep that in mind.
You had a question in the back?
I think it's been asked.
Okay,
Okay,
good.
go.
So null, it's problematic. Then for the post conditions, this is the standard format. So you have a general explanation of your function on the top. You have your parameters described like this, add param, and then you have the name of the parameter. So we have this function here, and it has an a and a b, and you write add param and then the name of this function, which is a, of this name of this parameter, which is a, and you describe, well, what is this description? And then when you have a return type, like we return an integer, you also have to say, okay, what do we actually return? So what is our return here? So when I graded my TA kids, I very often saw that they did not write this, they did not write this, and they did not write this. So it's very important to not only state that they exist, because we can already know that, but also, well, what do they do? What is their function? Can anybody want to try to say some good post documentation for this function? Can anybody give an attempt? So what would you write here for this specific function add? Just say something.
That it is an integer.
Number 1.
Alright, I'll give you an example then. So for this function add, something you could do is say, okay, this function sums two numbers. That's what this function does. Then a is the first number to be summed. It's very generic because it's just a very normal function, but you can write it like this. And then b is the second number to be summed. And then the return statement is the sum of the two numbers. It's very trivial, but you have to do this when they specifically ask for this. Also, please note, there are 2 stars over here. This is important. If you don't do 2 stars over here, it will be a regular comment, like we explained at the start. If you do the post conditions, you should do 2 stars, because then this will get highlighted, this will get highlighted, this will get highlighted.
Yeah, 2 stars at the top, 1 star at the bottom.
Exactly, very important. Alright. Then, oh yeah, when you don't have a return statement or you don't have parameters, doesn't matter, you can also have both. You don't have to include it, of course. So if you don't return anything, you only have to do this, or if you don't have any parameters, you don't have to write any parameters. So you only have to write whatever you actually use. So this is a function who does not have parameters, but does have a return statement, and then you just leave out the parameters, but you keep the return statement. Okay?
Alright, now we also have streams. So if you want to use writers and readers, and you want to read from a file or write to a file, then we can use streams, which are a series of bytes. You'll have streams more in depth in object-oriented programming, so we will not go too much in depth about what they actually are. But the main two that you will have to use is file input stream to get input from a file, and file output stream to get output as a file. So then we have readers and writers, and they convert bytes into chars, and that is why we use them to work with streams. So the output stream writer writes characters, specific characters, to a text file or something else, and input stream reader reads specific characters, well actually bytes, which it then transfers to characters from a specific text file.
Yeah, you don't have to remember this, but it's just how it works.
Yeah. So this is how you define them. Basically, you first define the new output stream writer, and then to get the input, to get the output to the output text, you use a file output stream, and then you use the name of the text file that you want the output to be outputted in. The same holds for the input stream reader, but then it's regarding input. So you create an input stream reader, and then you use a file input stream to read the input.txt. So basically, to read the input, you have a function called read, which actually reads an integer, but you can cast it to a chart to get the correct corresponding character. Basically, if you go to the next slide, we can return to this one later. You see that every specific character is linked to something called an ASCII number, and if you read from such a file, you will get this ASCII number. And if you then cast it to a char, your computer will know that, for example, number 75 belongs to a k. So if you have the number 75 and you cast it to a char and then you print it, you will get the letter k. If you do not cast it to a char, then it will print the number 75. But in reality, they're the same.
Yeah.
Could you go one slide back?
Yes.
Alright, so that's why we cast. And if you have read this character and you have casted to a character, then you can also write it using the output stream writer, and then it will be displayed in a text file. Always don't forget, once you're done using your output stream writer and your input stream writer, you also have to close them. You do that with a function called close, but that's pretty straightforward.
Yes, and also pay attention to the new keyword over here. It's in the corner, so you might not have noticed it.
Yeah.
It's important.
Wait 1 second.
Yeah.
You're also allowed to say file output stream and then give it a name, so you declare it as a variable and then add it in here, but it's easier and more convenient to do it in one line.
Everybody does it like this, so just remember this. It's much easier.
So an input stream reader basically just takes one character at a time, but if you want to get words, or you want to get I think an entire line actually, if you want to get an entire line, you use the buffered reader, which will read an entire line in a text file instead of reading character per character, but that's for different applications.
So just to be like 100% clear, probably a really stupid question.
No stupid questions.
Input stream reader is single characters and buffered reader is the entire.
Yes.
Yeah, but you wrap the input stream reader inside the buffered reader. So your input stream reader is inside of your buffered reader. So instead of just using the read function from your input stream reader, it will just read an entire line if you want to.
It uses the input stream reader and basically gives you the repeated input of an input machine reader, so you get an entire sentence instead of simple characters.
Yeah. So you get an entire line.
That's why it's called buffered instead of. Then we also have exceptions. Some functions throw exceptions. This is what happens when functions get input that they cannot deal with. If a function might throw an exception, you should always wrap it in a try-catch block. Just in case the program does throw an exception, you can and are able to catch it. So this would be the syntax. If you try something that might have input that might be wrong, or something that the function can't handle, you wrap it inside of a try function. So if something goes wrong, you are immediately able to catch it with the two catch clauses. And you can have multiple catch clauses for multiple types of exceptions. There are many. You have IO exceptions, null pointer exceptions, etc. You don't have to remember all of them by heart. But if you want to test for all of them, then you just put your code inside try and you can catch any of them. And once you've got them, you can execute a specific type of code. So instead of your program crashing, you can say, hey, I want to try this. If it doesn't work, then do this instead. And you can do that for multiple catch clauses.
Yeah, you can also do it for a single one. It doesn't have to be two. Yeah.
Do we have to know how to write this by hand? For the
Yes. I don't know if there are going to be questions about the input stream reader. It will be kind of cruel if they do it. It's a lot of code, but I mean technically they're not forced to not give you these questions. So I hope you don't get questions like this, but it's technically possible.
It's also very important to not just include the bits that you want to use the try for. If you want to add code, then you include all of it. So not only the parts that need the try. Basically, the entire segment of code that you want to test on, you put it inside the try.
So if some function inside your code throws an error, just wrap everything that is inside the function in the try catch, because it's much more nicer. So yeah, this is an example.
So yeah, the file input stream and the file output stream, for example, if you cannot find a file, it's not in the right path of your computer, then you might have a file not found exception. So if it cannot find the file, instead of crashing, it will actually just print file was not found. And if there another error occurs, an input-output exception, or I/O exception shortly, it will simply print something went wrong with the input-output. And if everything goes according to plan, then it will just execute this bit without a problem, and then it will continue after your catch clauses. So basically, this is just a function that reads from input text, and then reads the characters, and then writes it to output text, and afterwards, both of them are closed.
Yeah, and also it's very important to know, try catch is not the holy grail, so don't start using it everywhere to check if your code is broken or something. Only use it when it's absolutely necessary, otherwise your program won't run either.
Yeah, it's just important to use it whenever you have to deal with exceptions.
Yeah.
So it's very important to always catch file not found exceptions and I/O exceptions for the reasons we previously mentioned. If you do not check for these, then your program will crash while you have to handle them nicely.
Yeah. So only do this when you use the file input stream. If you don't, then you should not use these exceptions, because this is only linked to those two functions in this case. So if you just do 4 + 4, don't start working with file not found exceptions, because there's no file for 4 + 4, so there's no need to do that.
Sometimes you also want to throw exceptions yourself, since you want your program to stop in case something happens that's really bad. In that case, you can use throw. You can just throw your own exceptions thus. So you can use throw new. This is basically the format. You can use some exception and then the reason of your exception. And the one you likely saw in your assignments was new illegal argument exception, and then for example, an illegal character in the input. If you don't want the user to input slashes and you notice a slash, then you can throw an illegal argument exception. Hey, I found a slash, that's not allowed, so stop the program.
Yeah, and it just doesn't stop it in a normal way, it just crashes. So it's, if you don't do this when you could have continued, only do it when you really cannot continue.
Yeah, only when it's absolutely detrimental that you have to stop. Alright, erase.
Okay, so far we've only shown single values, but you can also have a list of values, and when a list of values is called an array. And you define an array basically in a sort of similar way as you define normal variables. However, you just add these parentheses over here, and you say, instead of, well, int number is 4, you say int, these parentheses numbers equals a new int, and then the size. You just have to remember this by heart. This is the way it is. If you want to do it for booleans, for instance, you have boolean occupied equals new boolean size. So this is the standard format.
Pay attention that this is not a capital.
Yes, it's also small letters. This is also small letters, but the string, a normal string, also does have a capital letter to start. So then there should be a capital letter. It's just the same type. You just add parentheses. Yes.
What does that?
What?
What does the second thing mean, like the boolean?
Yeah. So basically, what you say is an array occupied, and we set it equal to a new boolean array to this. But it can be many different types of arrays, and you'll learn more in object-oriented programming. You have different types of arrays. This is the most default one, but that's why there is a different way of writing it. So you basically say, okay, I make a new array, boolean, of type booleans. This is the type, and then this is how many elements there can be in your array. And you cannot change the size. So when you make this array, and you say, okay, this array has 3 spots in the array, then you cannot say, okay, later in my code I'm going to change it to 4 spots. So it just is a fixed size.
Then you would have to create a new array and move your elements to that new one if you do want to change
But that's
change the
way
size.
too difficult for this course,
Yeah.
so you don't have to remember this. Okay? So that's what that means. You just have to remember it for now. This is how you create an array. There's also a different way to create your array, because if you already want to add your values immediately, you can do so, and that looks like this. So for instance, in numbers, and I just want to add 1, 2, 3, and 4 as my values, then I can do it like this. So notice the curly brackets here instead of these square brackets. I don't like that, but that's the way Java does it. And same goes for booleans. You just give it default false true values. It also has a fixed size. So even though you don't say that it is a size of 4, it can deduce that from the context, and you still can change the size. So it's still a fixed size. Yeah, so that's what I tried to convey. After you declare your array, the size is fixed. You cannot change it. Elements of your array, you can get them by using their index position. And by this little piece of code here, you can see we start from 0. So the first element is at index 0, so at position 0, and it has the value 1 to make it confusing. But we start at index 0. So when we type, for instance, numbers 2 equals 10, then we change the number at position 2 in the array, which is this position, which is the 3. So we change the 3 to a 10. So basically, if you then try to print the numbers array, it will be 1, 2, 10, 4. Yeah?
And the size of this array would then be 3 or 4?
It will still be 4. It
Yeah,
will
the
still
size
be
will never
4
change.
big. Yeah. So the size does not start at 0, which is why which is why the size of your array or the maximum index position is your size minus 1. So your size is 4, but your last index position is 3 because we start at 0. It's confusing.
Yeah, we have 4 positions here, and the positions are labeled 0, 1, 2, and 3.
Yeah, so the last one is 3. Okay. Oh yeah, so here I set the value of cool, which is an integer, to the value at position 2 of my numbers array. So can somebody tell me, oh, I put it in blue, it's this value, it's 3. So it's 3, because it's position 2, it's the index, so we get 3, so cool will now be 3, because it's very cool.
Yeah. They're all still simple solo integers that
Yes.
just combined in a list together. So if you call in a position, then you have a single integer.
Exactly, so you can just you don't take it out, you just copy it. So you copy the value into cool. Okay, when you do this is a very common mistake. 4, it doesn't exist, so your program will crash. And I assume that when you do the assignments, this happened plenty of times. So it's very important if you use a for loop to go through your array, which you probably use a lot, that you always go until the size minus 1, which I can show somewhere here, I guess. Yeah, here. So because the length is 4 for our previous array, and we use smaller than, it will enter 3. So this is a very common way of looping through an array. At 4 items, I start with index 0, and with every iteration I increase my index, and I will continue until my index is no longer smaller than my size. And then it will be perfectly, will be designed in a perfect way, because 3 is still smaller than 4, so I can still get the third index. But then once it reaches 4, it's no longer smaller than the size, and it will just quit. So we have 5, 3, 2, and 1, and it will no longer crash.
What you also sometimes may see, although it's can you go back to that specific slide?
Yeah.
What you also sometimes may see, although I think it's it's uglier than this. Sometimes they add smaller than or equals, but then this has to be numbers.length minus 1.
Exactly. And an even more ugly way, but which they might use on the test to throw you off, is then they start with index your length minus 1, and then they will go down until it's no longer bigger than or equal than 0. So then they go the other way around,
Yeah.
which is to throw you off, but it's possible.
So you basically always have to check, as we mentioned before, what symbol is there, how many positions does my array have, and until when am I looping?
Yeah, because they are going to ask these kind of trick questions.
For smaller ones, for smaller arrays, it might be possible to write it out to get a clear overview for yourself, but as it becomes bigger, that might become tedious. So I would just check these 3 conditions for yourself, and then you'll probably figure it out.
Yeah. So, just about the default values, if you define it like this and you don't give it values, because it's an integer, it will have a default value of 0, and we have a nice table with the default values, like next slide I think. So it will be 0, 0, 0, 0. We have space for 4 integers, and by default, because we didn't give them any values yet, they will be 0. Yeah, so these are the default values what we were talking about. So for the integer it's 0, for double it's 0.0, which makes a difference because now it's a decimal number. For Boolean it's false by default. For a character you don't really have to know this, but it's nice that you know it. It's the character value in the ASCII table of 0. You never use it, it's weird, don't ignore this one. And for strings it's null. Like we told, if you have, that's why you have to assert on strings that they're not null, because by default strings are null and then they crash your program if you use anything without assigning them a value.
Can you go 1 back?
Yes. Yeah.
So if you don't add this bit and you add a semicolon here, then the array has not been initialized and the array itself will be null.
Ooh, that's a very good point. Yeah.
So that's why you also have to assert on arrays.
Yeah. Because if the array is, if you remove this exactly, like you said, it's null, and then your program also crashes.
Yeah. So right now you have 4 zeros because you said I want an array of integers, but you haven't specified which integers, so it will default 4 zeros. But if you don't specify that you want an array of integers, then the array will be null.
Yeah. Can I draw on here? Because then I want to. Yes, I can. So what if happens if I have a string? Okay, this is not allowed to work. Anyway, what happens if this is going to be a string and I write string over here? What will be the default output? So this one is a string and this one is a string. So how would this look? So what would be the output?
How would the 4 values look? What would
Yeah.
the 4 values look like? What did you say?
I think that it's null.
Only null? It's
Oh yeah, yeah. As you said,
yeah,
multiple.
multiple nulls. Yeah, exactly. So
exactly.
it's null, comma null, comma null, comma null.
Yeah.
It's different than just leaving this out because then it's null in general. Yeah. Okay.
Each value in the array will take the value null. Well, yeah, it's not a value. Each value will default to null because the default value for string is null.
Yes. All right. So then we had this as well. Okay. Then because we looped here for until the index was no longer smaller than the length of the array numbers. But you can also do this for strings, but for strings it's a little bit more tricky because then it's a function or method and then you have to add parentheses after it. So for arrays you should not use parentheses after the length, and for strings you should. This is very tricky, remember this, because there could be a question in a test and then you might do it wrong. Like if you just program in IntelliJ, it will help you and say, okay, this is wrong, but on paper it will not help you.
Yeah.
So
what they often
keep this in
do
mind.
is they have a question where you have to correct a specific method or function, and they might sneak in some parentheses after for an array, or they might leave out them for strings. It can be hard to spot, but now you know the difference.
yes, which is why you're gonna get a 10 for the test. Alright, and then you can also index on strings. So you can get specific characters from a string, just as if it was an array. And the way you do that is you say .char add and then the index. Again, here we start at 0, so 1 will be the E if we use hello world. Because this is the second one is like 0, 1, so this will be the E. So you can get the specific character inside a string. Note that it has a single quotation marks because it's a char. So it's not a string, you get a char back. Then you can also get a part of the string that's multiple characters, and you can do this with substring. And it's the from index, so from 1, so 0, 1. And then the last one, this one, is the to, but it's excluding. So 0, 1, 2, 3, 4, 5. So it's everything except this space. So it's ELLO. Yes, it's excluding the last one. Alright, so this is how you do string indexing. Then we can also make our enums an array. The way you do this is by calling the dot values on the type. Okay, this one is really a bit advanced, and I hope you don't have to use it, but it's good to know that you can do this in the future. So we have our enum day, which can take all of these values. So Monday, Tuesday, Wednesday, Thursday, Saturday, Sunday, and also Friday, which I forgot. And then you can get the values associated with this type by typing day with the capital letter, because you're doing it on the type, dot values, and then it will create an array with all of these enum values separately, which can be useful if you're looping through all the possible options in the for loop. You don't have to use it probably, but it's good to know that you can, because this can be very helpful for programming too, and object-oriented programming.
Yeah, why it looks like that will also probably become clearer after you've had object-oriented
Yes,
programming.
because until now we've only used functions on the actual name. So for instance, input.nextInt, but here we're actually doing it on the type. So
Yeah.
it's like if you say string dot something, which
That's
is all only for this one so far, and then will be explained in object-oriented programming.
And that's also the difference with the previous functions. Previous functions were called on day.mon.ordinal,
Yes.
for example, or day.mon.name. And the values one is called on the type, as Johan said already.
Yeah. So this one is called on the day.to, the Tuesday, the value, and we just get the ordinal for this one, but the values, it's on the day. So that's a very subtle difference. You don't have to use it, but it's good to know that it exists. This can be really useful in the future. Okay, then we are at multi-dimensional arrays.
Yes. So basically, you can also have an array inside of an array, which makes for a multi-dimensional array. You can declare a multi-dimensional array by adding more braces,
Yes.
square brackets to them, and then you would also have to add another number for the size. Again, it's an array. These sizes cannot be changed after you've instantiated your array. So for example, here we create a two-dimensional numbers array, both with 5 rows and 5 columns. These numbers do not have to be the same, by the way. They can be different, but if you want to make like a square, then you can use 5 and 5, the same number. But you should visualize it as, I think that's on the next slide.
Yes. But
should
by the way, I also remembered that it was on the slide, but I don't think we explicitly mentioned it. An array can only have one type in it. So if you have like an int array, it can only have integers inside the array. But it was on the slide, but we forgot to mention it.
Yeah. So yeah, if you can go to the next slide. Basically, it's an array inside of an array, as I've mentioned before. So this array would have this array in it, this array in it, this array in it, this array, and that array. And then you can also index through these multi-dimensional array. So for example, we have an array of 5 here. So you look at, if you want to look at the 4th one, that's the last one, as we start at 0. So then that would be this one. And then you want to look at the 3rd position, so 0, 1, 2, 3. So if you want to change this number, you change the 4th row, so actually that's the 5th row, and the 4th position, which is position number 3. And if you change that to 5, then this will also become 5. And then the rest, as we haven't set any of the other positions yet, all of them have defaulted to 0.
Yeah.
Is that clear for everyone?
Yes, like this is how it would look.
Yeah.
If you were to define it with value, with code.
So these two are for the outer array, and all the arrays inside also have their own curly braces.
Okay. And you can also define it like this. This is valid code. This would run. So where we just like with single arrays. Let me just go back and show you real quick. With single arrays, you would create it like
There was also
this. you can also, for instance, do that for multidimensional. So both this and this is valid, and for multidimensional arrays, the same thing goes. That both this, like this here, this is valid, and this is also valid.
Yeah. You can go one back.
Back? Yeah.
Do note that you always do have to add a size though if you do it like this. That's
Yeah.
important.
And the semicolon.
Alright, so we have a couple of questions for you guys. If you want to get this position, which number would that be? Mm-hmm.
6?
It will show all of them if you go down one.
Oh, it is, okay.
Yeah.
Okay, so that's true, it's 6.
And the next one?
Probably the whole third one.
Yeah, so it will just return the entire array, we'll show it in a bit.
Yeah.
And what will be P and Q in this case?
The first one would be 1 for P and Q. So 1? No.
There's only 1 9 in it here.
Three,
So
one.
which positions would they be?
Yeah, 3.
3, 1. Yeah, that's correct. Okay, so yeah, this one is a bit tricky. You can do this, so this is just valid, but then you'll get an array of integers because that's what's in this part.
Yeah.
Make sense?
So basically, multidimensional arrays are not limited by 2 dimensions. They can have 3 dimensions, 4 dimensions, 17 dimensions if you like, but you will not see this on your test, so don't worry about it.
It's just that you know that it can be done and it is possible.
All right.
Yeah?
Yeah. Okay. So basically, variables get saved in memory, because arrays can be arrays can be very large. It's more efficient to reference an existing array, other than simply copying it every time a value gets changed, or you want to copy it to a different variable name, stuff like that. Because then your memory will get very full. You just want to reference to that existing array. And that is why we have call by value and call by reference. All of these are call by value. So if you change them inside a different function, then the original variable will not get changed. But if you change an array inside of a different function, then the array will be changed because you referenced the original array.
You will see plenty of examples we'll show
Yeah.
you. So if you don't understand now, that's not a big issue.
Mm-hmm.
Real quick, here they get copied, and for call by reference they get referenced.
So yeah, basically we have a main function here. You have an x, which we set to 1, and then we have an y, which we set to 0, with x as a parameter. And then here, this function would set the number j to 0. Well, we get a number j as a parameter, which is then set to 0, and then we return j. So what would y be right now?
0.
Yeah.
Correct?
And what would x be?
Wrong.
1?
Yeah,
Correct?
true. Because while j was passed as a parameter and it was set to 0 here, this x was left untouched because this value was copied. As x is an int, and ints are called by value. So if you pass it on to a different function, then the original x will not change unless you actually say x is now this value. The original x will not change. That's what call by value means.
Wait, what do you mean? So like, just the x in the static void won't change, but the one in the set to 0 will change.
Yes, but that's not x, so that's j. It's a copy.
It's basically a copy. We could have also named this x.
To make it more confusing.
Yeah. So this x gets passed on as a parameter. So you just want to use the value that x is currently has. So now when 1 gets passed as a parameter, this j becomes 1, but then the j is set to 0 and returned. So basically, the y is now a 0 because we said return 0, but this x was left untouched because we did pass the 1 on as a parameter, but we did not change this value.
So it's like a storage unit?
No, look, maybe I can draw, I hope it does work. Yeah, so now if you do set to 0 x, 1 will go to j, now j will be 0, so now 0 will be returned, and because we return 0, this will now become 0, y will now be 0, and x is still the same.
Yeah, we never said x is now this, so that's why x will still have the value of 1.
Makes sense? Okay.
But then for arrays, that's a different story, because if you pass an array onto a different function, and you change something inside that function, the original array will change as well. This is because we reference the original array. Basically, if you create an array, you will put it into memory, and every time you change something about that array, or you, basically if you change something about that array, it will still go to that same bit of memory that you originally created the array in, and it will say, okay, so hey, this is my array, I just changed that value in that function, now change the original array.
Yeah, so this one is a bit more tricky to understand, we also have examples.
So basically we have a similar function. We have an array which only contains the number 1. We have a set to 0 function again, and basically we take the value on position 0, we set it to 0, and then we return this array again. Basically what it means is that what would you think y is now?
So what will be y?
I think 0 and 1.
This one, this is 0. I mean, do you mean this?
No.
Okay.
Yeah, they're both integer arrays, so the output will also be an array, as we set it position to 0. So that's first. And secondly, because arrays are called by reference, since we changed the array we passed as a parameter here to 0 in this position, x will have changed as well. That's a property of
So the answer
arrays.
is this, and it might not what you expect. Y will be 0. Now, just like with normal integers, it will be changed, it will be returned. So we change the original array that comes in. It has 1 value. It makes it maybe a bit confusing, but it could have 2, 3, 4. It only has 1 value in this case. Then we change the element at the 0th position, which is this thing here. So now, where j first was 1, in curly braces, we now change the first position, the 0th position, to 0. So now j would be equal to this, and then we return this. So now this would be this, so that's what you would expect. So that y, of course, is 0, and you might expect that x is still 1, because we didn't touch it, just like last time. But because arrays can be very big, if you change something in the array, it will change it everywhere you use that array. So this x, it will just pass not only the value, but it will just pass the entire array on. So if you change it over here, it will also change over here. So now we change it here, it will change here, so this will also become a 0. It might not be logical, but yeah, this is how arrays work. So when you change it somewhere, because this is the x, it will change over here. Yeah?
So if you change one value, the entire, like all values change?
No, not all values.
No.
So when
if there
we
would have been 2 values here, and you would change one value in this function, then that single value will also be alternated here
So
on the
this is
same
all
position.
one array?
Sorry?
Or you have like multiple arrays, or this is all one array?
This is
with
just
the same-
one simple array with one value. So it's an array, an int array with size 1. If you were to have an int array with size 2, so you would have to have 1, comma 2, for example, and you would change the 0th position, then the 0th position in this one would also change to 0, but the 2 would still be there.
Yeah. So the point we try to make is not that every element inside this array changes, just like I said, like if you have multiple chinks, it would just be this.
Yeah.
So if this would have been 1, 2, 3, then the result would be 0, comma 2, comma 3 for both. So the point we make is not that all the values inside the array change, but everywhere this specific array is used, it will be changed. So also x will be changed, and y also will be changed, because y is the return value, so that's logical. But x is also changed because we don't only pass the value of x, we don't only pass the what's behind it, we just change everything. So we just change an x completely.
Yeah.
This might not be fully related, but what does did we create a new array called y? Or
Yeah, so we created this right here. Now it's a little bit messy.
Yeah, and a complicated thing might now also be that because y and x are referencing the same array, if you change y, then you also change x right now.
Yeah, so
Because they're talking about the same array, they just have different variable names, but they point to the same specific array in memory.
yeah.
So if you change something in x, then y also changes, and if something changes in y, then x also changes.
A way to think of this might be then to, instead of, so I can give you a card, and I can say give you the card 5, and I can give you the card 5. Now I change your value 5 to 3, but you still have different cards. So you have 5 and you have 3, yeah? If I gave you an array, it will be much like, okay, I give you an address to my postal location, it's a mailbox, and I'll give you also the same address to the postal location. Now I go to my mailbox, and I change the card inside my mailbox from 5 to 3. When you go look in your mailbox, you both now have a changed value in the mailbox. But I only change one thing, I only change the thing inside my mailbox. But the value of both your numbers, both your cards changed because you all have the same mailbox, yeah? So that's the difference. Instead of changing the card you specifically have, I don't change what it references to, I don't change the location of my mailbox, but I just change what's inside my mailbox. And because you both have the same address of the mailbox, you'll both be shocked that I changed the card from 5 to 3. Yeah?
And there's one more important thing. This property actually allows you, so basically, if you pass an array as a parameter and then you change something, you don't actually have to, this function can be void, you don't actually have to return it. Because if you change something inside this function, then the original array will be changed anyway.
Yeah.
So you don't have to say, return my array to get it back here, because this array will be changed if you change it inside the function.
Okay.
Do pay attention to the fact that this has to be void then, because this requires a return, but if you don't want to return something, then you change this to void. It's just a property of call by reference. You don't have to use a return.
What happens?
We have to
Wait, I changed something. Oops, okay. Anyway,
Is that clear to everyone?
so when we make this void exactly, so that this will become void, we remove the return statement, then we cannot no longer do this anymore, but now still x would be 0 in this case.
Yeah.
Because we changed it over here, it's really messy, I tried to find an eraser but I couldn't.
Yeah. So it's still talking about the same array, basically. That's why you don't have to return.
Okay. Now, last one. Oh, that was
so
the
yeah.
last one.
So we have a little break again, and then we can try to do an exercise together.
Yeah, just only very short because we only have like 25 minutes left.
Yeah, sure.
Yeah, 5 minutes break, and
minutes.
then. Alright, okay.
And I really want
Yes. Wil je de camera nog wat draaien,
Ja.
dus dat jij
Zo.
erop staat?
Ja.
Als jij even wil, dan het ding ook, dan kun je dat. Zo goed.
Yeah, that's fine. Okay, we're back. Do you want to see anything in practice? Like, what do you have something that you want us to see program live? Is there anything you are not certain about and that you would like us to program here? Otherwise, we'll just do examples ourselves. No?
Basically anything is possible.
You can ask us anything. Yeah.
maybe something with multi-dimensional arrays.
Yeah, that's a good one. Okay, so we have.
Sudoku solver.
Yeah, let's create that.
We don't have enough time for that. Okay,
So
so.
Minimax?
Hmm?
You could speed code Minimax. I need it for Int.
Alright, so I'm first going to start by making a different function because I don't like to have everything in the main function. So I'll, for instance, make a function. What's a good example for a multi-dimensional array?
You can show a double for loop.
Double for loop, that's a good one. Okay. So I'm going to make a multi-dimensional array and then I'm going to make a function that increments every value in this multi-dimensional array by 1. Yeah? So I'm first going to make a void increment, public static void increment, and it will basically increment every value in this array. And then we also can see how pass by reference.
Yeah.
How is it called again?
Pass by reference.
Call by reference.
Call by
How
reference.
call
You
by
don't-
reference works.
So basically you don't have to use a return statement.
Exactly. Yeah. So I'll just call this values. Yeah, this should be a small letter. I'm sorry. So this is the array that's going to increment every value in this array by 1. Now, we don't have an array yet, so let's first make that one. And it's going to be a multi-dimensional array. So I'm going to have 2 dimensions, so it's basically a table. And I'm going to call this one values. And I'll set it equal to a new integer with a size of, let's do 2 different values. So it's going to be 10 high, so 10 rows. Why is this not working? 10 high, yes, and 5 wide.
Alright, so what will be the default values of this entire array?
Yes.
Yes, a lot of zeros.
Yes, so
Because they're
5
integers.
zeros in a row and then 10 columns, no, 10 rows. 10 like this, 5 like this.
Maybe you can show it like with a print statement right now.
Yes, I can.
Don't forget to add the semicolon.
Oh yeah, I do that sometimes. So there should be a semicolon here. Arrays dot. What was the thing before array?
ToString.
String. Yes. Okay, you don't have to remember this, but it's just for demonstrative purposes to show you how the array looks. Okay, this is really bad. Why can't I just copy it? Okay.
You have to call the function still.
Yes, this is about that. Okay, so this is basically just for demonstrative purposes to show you how the array looks. You don't have to know this function
And semicolon.
and the semicolon, like always.
For system out print.
Yes. Okay, so is it doing anything? If not, we probably didn't import arrays. This is a very bad compiler.
Maybe just show a couple of positions instead of
Okay,
the entire
anyway,
array.
just believe us that it's a array. So it will look like this. 0, 0, 0, 0. That's the first, another one. And we have this for multiple lines. So I'm going to do this like this. Oh, this is really bad demonstration. Okay, this is far worse than IntelliJ. And then this 10 rows long. So this is how it looked. Okay, I'm really struggling
Yeah,
with this.
currently it's just all zeros basically.
Yeah, it does this and then a comma there. Okay, and that's on 10 rows long. I guess you get the point by now.
Mm-hmm.
Okay, so now that we have this array created right here, it's a new multidimensional array and it all has zeros. We're passing it along to the increment function with values, and we get it over here. Now, what we can do with it is the following. I can say, okay, 4. And I'm going to call this one, for instance, row. For every row, and we start with row equals 0. So we start with the 0th row.
Yes. Do
And
we
then
now
we
use
say-
length with parentheses or length without parentheses?
Yeah, so now we want to do this for the entire length of the array.
So which length would we use? Yes, correct. Because we are talking about
Exactly.
arrays and not strings.
So we say values dot length over here without parentheses. And then we increment the rows by 1. So now we go through all the rows. We start at row 0 until we are at the last row. And we want to do this because we want to increment every value in the array. So now we have in our for loop, we have an index 0. So we could, for instance, say, okay, values 0. And then we have the 0th index of this multidimensional array, but it's 2 dimensions and we want to change every value. So we also need a value for the column. How can we do this? Well, we're going to do another for loop inside this for loop. And in this case it's the column, and we start at 0. And then we say, okay, while the column is smaller than, and now this part is maybe a little bit tricky, because how do I get the length of the, how do I get the width of the array? Because for the length, or for the height, I use dot length, but how am I going to get the length of the, or like the width? Do you have any ideas how we could do this? Alright, do you remember where with the presentation we had a slide where we showed you that when you do values like this 0, you get an array. You get the entire row at a certain index. And that's another array. So we can call the length of that row. So what we can say here is we can say, okay, for every call where column is smaller than the array at the 0th position, or like actually at the row, that would be nicer, I guess, even though it doesn't change. So now we get the array at the certain row, and we just check, okay, what's the length of this array? That's the width. Yeah. So I can maybe show that in the over here. So also do it for the stream, so
Wait,
that
should it not be
everybody
0?
can see it.
Because row will increase. I think
Yeah,
it should
but
be 0, right?
No, it doesn't really matter.
Yeah,
because
no, it doesn't matter.
I can
Fair.
do that as well. So now they can also see the thing. At a certain index, at index 0 or row, it doesn't really matter, you get an array back. So you get an array and you can check the length of that array, and then you have the width. Okay? So let's go back to the thing here. Okay? So we can now get the width of the multidimensional array, and then we can say, okay, we increase the column, and this is also a for loop. So now we have a double for loop, and inside in this for loop we have access to the row and the column that we're currently working with. So I can now target a values at a certain position, namely at a certain row and at a certain column. And by doing this, I can increment it by 1. I can just say, okay, because this is a multidimensional int array, the value at this place, it's an int. So I could, for instance, say int value is equal to this. And now I can say value or system.out dot print line value. And now I hope that it doesn't complain about system. Yeah. So now it shows every single element inside this array. Yeah? Does that make sense? Because we now have access to the row and the column, and we just loop through both of them. And for every row, we check through all the columns, and then we do this for every row, so we get all the values. So now what I can do is I can say, okay, well, I can say, okay, value is this, but I can also say, okay, well, I just want to change the value at this position. So I want to set this to, right, let's just first do it a bit differently. So I can say, now that I have the value, it's 0 at this position. I can set the position of this to value plus 1. And if I now print it right here, it will just all be 1s. Just without the print line. This over here. So if I now, okay, this is really weird website. Okay.
Don't forget the semicolon.
I don't forget the semicolon. Yes, I did. So now it should say once for everything. Yeah. So now I changed the value at the certain row and column to its previous value plus 1. And now I print it. It's pretty useless, but this is how the array looks right now. Okay, but I can do this in a smarter way, because I say is value plus 1. We have learned about different ways to increment, like plus equals or something. So a trick I could do is I could say, okay, values row column plus equals 1. Now, and you would say, okay, how does this work? Why does this work? Let's show first that it works. And this should basically say the same. Let's hope it does. Yeah. So this also works. Now, why does this work? Because the values at row column is an integer. Yes, because our multiple, it's an array of integers in rows and in columns. Or columns, yeah, in rows and in columns. So a single value out of this array is of type integer. And I can add 1 to that integer. And because I change it immediately by doing plus equals, I change it at this position, it will immediately change the array. So now I basically increment everything in the array. Now, you can see the for loop is very small, it's just a single line. And when it's a single line, I am allowed to remove the parentheses. Now I need to scroll to the right. And now I can show you that it also works, because it's also a topic we covered in the crash course. So we can remove this parentheses, and we can remove this one as well. Because in theory, you would say, okay, but there's 2 lines in here, but this is just a single line. I could just write this like this, and it would still work, because there's only 1 semicolon. I could make it one very big row and make it very unreadable, but this is, technically it's still 1 row, because there's only 1 semicolon at the end. So I can write a double for loop if it only has the single, line of code. I can write it without parentheses.
So basically, the amount of lines gets determined by the amount of semicolons.
Yeah.
I'm wondering whether plus plus will work at
Yeah,
Plus
it would also work.
It would also work. Let's see if it works. I'll show you. And I'll also prove that you can do this without parentheses. It can only work because of 1 line. Again, you should not do this normally.
There's no print. That's why it doesn't print.
There's no print. Oh, good point. Okay, before I'm going to show you this, I'm going to show you how the by reference works. Because now in a different array, without even returning anything, because arrays are called by reference, it is changed over here. So
yeah, use the double for loop.
yeah, I will just show you the value at 0, 0, and this should be 1.
Semicolon.
Semicolon, which thing? Yeah, so I always forget my semicolons. And this should be 1. Yeah. So we increment it inside this function. We increment all values of the array, and because we pass it by reference, it just changes the array everywhere. And this array is this array, because we call it over here. And when we then say, okay, I want to get the element index 0 in the row and in the column, and the row and then 0 in the column as well, then we target it from this array, which was passed over here, which was changed over here. So this will now also be a 1. That's how the call by reference works in practice. If this, for instance, would have been a number, So let's say this is not a multidimensional array, but this is just a single value. I'll give it a more appropriate name, and I'll say, okay, this is 0, or I don't even have to define it at all because it will be 0 by default, but let's not do that, that's best practice. And I'll say, okay, increment value, and value will receive a one-dimensional, or just like an int. I can just say, okay, value plus plus. You normally should not make a function for this, but this is demonstrative. This for demonstrative purposes. I can now print value here, and you will see that it will still be 0, because it was a copy. Yeah. So even though it's changed in this function, we don't see the difference here because it just passes a copy. So it basically says, okay, I'm going to pass 0 here, and then this will also become 0 now. So now int value is like equal to 0. So now this will be 0 plus plus. So there will just be a 1 here. We don't return anything, so it will just be 1 and it will be odd. You don't do anything with it. But this 0 doesn't change, so we still get 0 here.
So if you do want to change it, you would have to add a return statement. You have to change that to int, and you have to say value equals, and then your function.
So you can even do this inside the return, and it will just return 1, and now I can say increment my value.
And then value equals increment.
Exactly. And then we reset the value of value to this new function, which will now increment our original value by 1. And now we print it, and now it should be 1. It's not 1. Okay. What did I do wrong?
What will you, is it the right place for return?
Maybe because I cannot.
Maybe just say +1.
Yeah, value equals value plus 1. Maybe this changes it. Yeah, okay, now this okay.
So maybe in a return statement you cannot say ++.
Yeah, you should do it in different, but it's out of the scope. So you can do this, but then it should be 1, but why I'm not going to tell you, it's out of the scope. So basically if you do the plus plus, that's also a downside. We didn't explain that because I didn't think it was necessary. But if you do plus plus at the end, it will increment after it has done the return, which makes no sense. And I don't know why it doesn't do it in here, but if you do it before, it will just change it before it does anything else. But you should not do that.
Just remember that you can use ++ in loops.
Yeah.
Sometimes that's nice,
Yeah.
but it's risky because it might go wrong more quickly and you can only use it for 1.
So plus equals 1 is safer.
Safer.
So
yeah.
just stick to plus equals 1 for now. Okay. Any other questions? Yeah. Okay. So now we're going to show you how you can throw an error. It's a very good question. Okay. So maybe we have a function. Okay. What would be a good example?
What?
Oh, damn, yeah. It's
Dames en heren, gaat Maria Montessori gebouw gaat sluiten.
Maybe we can quickly.
That's unfortunate.
Maybe you can do like if the number is below 0 for square root, then you can throw an error.
Okay. Very quickly then. Square root. So we just have a value. We have a function called square root. It returns a double. And this. Then we have a value, and we want to take the square root of this. And normally you would do this with the search statements, but just for demonstrative purposes only, we will throw a new error. So we can just say, okay, if value is smaller than 0, then we are going to throw new legal argument exception. And it's going to say, okay, well, can't take square root of a negative number.
And then semicolon.
And a semicolon. And now we throw a new exception and our program will crash, and that's exactly what we want. And now we need to still call it, so we just say, okay, take the square root, so it says sqrt of minus 1.0,
We need to change
because
it
it
to
needs
void.
to take a double, and I need to change to that's correct. Okay, now we don't return anything because it's just to show you how to throw an error. And we now say, okay, you have a new illegal argument. Oh, I forgot my semicolon, of course, again, as usual. And hopefully, yeah, illegal argument exception.
Illegal argument exception
It
can take square root of negative number.
Alright, so this is the crash course. It was very little demonstration, but yeah, it was a lot of theory. We chose to just go through all the concepts, and because we hoped that it would make it more clear for you. And I think we succeeded in that. So good luck with the exam.
Yeah, definitely. And you can find the slides online as stated, so if you want to have a recap for yourself, that's possible. Also, this crash course will be found online. So yeah, and fortunately you have the first year's chat to ask questions in as well.
Yeah. Okay. Thank you for your attention.
Good luck studying.